So, hello everyone, and today we will be seeing a blog post. You see, there are multiple interviews for getting a job. Most of the interviews revolved around DSA and coding. On the other hand, Stripe is such a company or organization which doesn't focus on DSA. It mostly focuses on how you approach the problem, what's the development, efforts you can take, what's the thinking you do, what's the design decisions you make, and based on that, they are going to hire you. And again, this is debatable whether it is good or bad. I think it is interesting. It is fairly interesting because apart from them, there are only few folks who does this. Stripe is one of them, and I think Atlassian is one another company which kind of follows mixed approach. They take some of a DSA and some of designing decisions, and it's kind of mix of it. But see, I this article in turn caught my eye. It says the Stripe system design question that separates senior from staff engineers, and yeah, let's check it out what the author has to say. So most candidates answer the wrong question entirely. Here is why the stakes are higher than they appear. Stripe processes hundreds of millions of payment requests every year. Each one touches a bank or a card network or a merchant account and a chain of internal services. I do agree to that. In fact, Stripe had their own principle, their own convention, which was so solid, and developers were quite interested within this Stripe APIs because they provide us functionality. Okay, not jumping into the side track. Now picture this: a network blip calls your client to retry a charge. Did the first attempt go through? You genuinely don't know. Genuinely don't know. Sorry. The customer might be charged twice. The merchant might fulfill the same order twice. The bank might flag the account for suspicious activity. How do you guarantee that a payment executes exactly once in a system where nothing is guaranteed? And that is very fair question. And such kind of scenarios, if you are not aware much, are known as idempotency, where you fire a request, let's say create an account. In this case, it's a very critical request of payment. So create an account, payment. Client generally what it does, it retries from its own end to the server if it finds out the timeout and whatnot things, and it's server's responsibility generally not to do that, and it's a very good thing to take it into a server's responsibility because again, client can imitate these things and you don't want this. So on the server side, you don't want to repeat this kind of things. There are two aspects of this. It would avoid the replay attacks, and most important, the functional aspect is it would provide you idempotency within the request. So generally the post request are such kind of things which you want to have an idempotency. You don't want to charge multiple times, and you want it to get through it. And yeah, that is the question, and the way you answer it tells Stripe a great deal about where you are in your career. The deceptive is simple question. The problem sounds almost trivial when you first hear it. A user clicks pay, you call the payments API, you store the result, done. But the interviewer is not asking about the happy part. They are asking what happens in the gap between sending the request and confirming its result. The gap is where the distributed system gets genuinely interesting. Most candidates hear payment system, and yeah, this is the problem with most of the candidates over here. Even I have interviewed and I have given the interviews as well, and often times we tend to jump onto a solution rather than understanding what we are trying to build. And yeah, I learned it a hard way. I lost one or two interviews, I guess, because of this. But yeah, I'm sharing my experience. You can share yours as well. I give a read to every of the comment which you mentioned. But yeah, most of candidates hear payment system and immediately jump to the database schema, microservices boundaries, and API rate limits. All of those matter, none of them are core of the question. Cannot emphasize more on these two sentences. Can I? Okay, I cannot. Okay, cool. If I could highlight this, I can highlight that. The core is this: in a distributed system, you do not get exactly one execution for free. You get most once, which risk losing data, or at least once, which risks duplicating side effects. Okay, let me shed some light. There are few concepts like most ones or least ones. Least ones, if I can mention it, that within the system of, let's say, very simple system, client and server, the client can send the request at least once, and for server it is at most once he can execute it. That's the generic understanding when we are building the system. And the more deeper you go into this, and the more critical you think that, hey, these are the things which we tend to neglect, and that's the reason a system might go into an overhead or misbehave. Again, if I can pinpoint the example, let's take an example of queue. You don't want queue to retry a single message to multiple times. It should guarantee at least once delivery, and it should ensure that and the consumer should ensure that at most once a request has been executed. Exactly once is a property. Okay, the guy has mentioned already. Nice. Exactly once is a property you have to build yourself at the application layer. The question is testing whether you know that. He didn't mention it. Okay, but we have to do it. Yeah. It's the same thing which I explained to you earlier. And he mentioned that it needs to be done in application layer, and that's a very good thing. It's questionable whether application layer is a good part or not, but yeah, it's a very good start for me if I was into the picture. In a huge scale, you can rely on SQS or Kafka. At any meaningful scale, this breaks because a retry is completely indistinguishable from a new request unless you build a mechanism that makes them distinguishable. Exactly. This is so important. So the senior's answer. Now consider the senior is not a very profound person. Senior is still learning person. He's not yet staff, that's the reason he's senior. The correct response at the senior level is idempotency keys, which is something very basic which I mentioned. The client guarantees a unique identifier for each intended operation and sends it alongside every request. The server stores that key and its result. If the same key arrives again, the server returns the stored result without re-executing the underlying logic. In plain terms, you are trading storage for safety. Every intended operation gets fingerprint. The fingerprint survives the retry. And yeah, this is pretty standard. And if you're short on if you're short on memory or storage or cache, whatever you wanted to say, you can have an eviction policy of 60 minutes, you can say, as per your businesses. If your business wants 60 minutes to be a session timeouts, go ahead. 15-minute session timeouts, go ahead. Stripe's public documentation describes exactly this pattern. Clients pass an idempotency key header. The server uses it to deduplicate request. This is the right answer, and it earns full credit at a senior level. Again, at a senior level, this is questionable. Why? It's clean, it is well understood, and it solves the duplicate charge problem in the straightforward case. A senior engineer would be able to explain it clearly, describe how to store and expire idempotency record. Just we know eviction policies, yeah, and walk through the happy paths end to end. But here is where most people stop, and stopping here is what separates a senior engineer answer from a staff one. Now let's see what the staff answers. The staff level follow-ups is what happens between receiving the idempotency and writing the result. Walk through this carefully. Your service receives a request with a fresh idempotency key. It charges the card. It prevents to write success to an idempotency store. Then the server crashes, and this is where the horses in your mind blows. Like, this is where the direction of thinking goes for a staff. In a senior level, I'm sure you might not have went through the server crashes and the resiliency and the recovery algorithms anyway. But going ahead, what if the server crashes? Yeah, the response never reaches the client. The client retries with the same key. No result exists in the store. The server charges the card again, and my friend, your card is being charged again. That is what the whole point of the idempotency was, and this deceptive question is true. Now, how can we handle this? You can recreate the original problem inside your solution, and that is what it is explained in this here. The fix is to treat idempotency record as a state machine rather than a simple key value pair. Before executing the operation, write a record in an in progress state. After completing it, transition to completed and store the result. On any retry, if the state is in progress, return a conflict response and ask the client to wait. If the state is completed, return the cached result. If no record exists, begin fresh. And this is so smart. This is so smart in a way that you don't work within a 0 or 1. It is smart in a way that, if I can open draw, I guess, open desktop, what was the annotation tool? Anyways, this is so sweet because you have now understanding whether what process I was at and what process should I continue. This is an approach most team converge on at the scale, because on publicly available engineering literature on payment system design, it turns a deceptive simple cache into a coordination mechanism. If two retries arrive simultaneously before either has finished, you need a compare and swap operation or distributed lock on the idempotency record. Now, too many jargons over here, but I would try to simplify it. Now, it highlights a race condition where two retry requests arrive simultaneously. And the race condition, why? Because either of them has not finished yet. Both are at the doorstep. Now, the algorithm should do what it should do is, we need to compare and swap the operation in a way or a distributed lock in an idempotency record. So we have an idempotency record. Let's assume it's a cache or a database. Now we need to apply a lock before doing any of the operation, and only one execution can hold in progress. Yeah, this is where it is at a time. If another request comes, it should not go into in progress, and that's where the logic comes in. That's where the thread safety should go in. That's where you need to handle the concurrency in an efficient way. Let's imagine, what if I don't do it? What if I have a two in progress items? Now your state machine is useless. You don't know which in progress should I mark it into done. Now you can take a call. I can mark this in progress into done. But wait a second. For in progress to done, you need to make a call to your card, or you need to charge to your card. Anyways, whether you are charging, transiting from in progress to done, you are making anyways two calls, because you have two in progress items within your database. and that's not what is expected. This adds a latency, which is the real cost, and this is where the trade-offs kicks in. We often mention that hey, we need to deal with a trade-off, but this is where the trade-off kicks in, where we cannot allow two in progresses, but we need to add locks, and that will cost time, and this is a trade-off. And it means your idempotency store becomes a critical path dependency, whose availability directly affects your payment success rate. The trade-off, latency and availability for correctness, is what the question is really probing. Now what's the hidden dimensions? Now we understood what we are looking for. We also got a gist upon what the solution we can provide. Let's see the hidden dimension. Most engineers feel confident once they reach the state machine answer. Here is the harder question underneath it. What happens when your payment service calls 3 downstream services and one of them fails halfway through? You have already notified the bank. You have not updated the merchant's inventory. You have not sent the confirmation email yet. Your idempotency keys covers the top level request. It does not automatically coordinate with the state of every service you called on the way. Now this is very interesting because idempotency key, where we have used, it only covered the retries and the way how we deal with multiple charges. But once the charge is completed, we have to notify the bank, and in our scenario we have already did that. Hey, bank, we are charging and you can proceed with the payment, because we are just payment processors and we are not the payment issuer. Bank is an issuer. You have not updated the merchant inventory, and that is true because our services died, and since merchant inventory is not updated, we cannot send the confirmation email, or else it is also down. We don't know. So yeah, what can we do now? This is a boundary between idempotency and a transition management across the services, and it is where the saga pattern leaves. If you're unsure of what patterns these are, saga, state machine, you can click the video over here. I have written a blog. You can click the link over here. Sorry, not a video. I have written a blog over there what patterns means and how you can get started with these design patterns efficiently in a very beginner to intermediate level, from the beginner to intermediate level, and you can excel to the expert step by step as per your need. If you wanted to stay at intermediate, just go and take a look. If you want to go to expert, you can just complete it all. You can click it over here, and I'm planning to generate a videos as well. Let's see how it goes. Now what it says is it comes a saga pattern. A saga breaks a distribution transaction into sequence of local transaction, each with a corresponding compensation action that can undo it if later step fails. And this is where things get interesting, because now you're not looking at the only one pattern, but you are looking at the whole picture of it. And this is what makes you not the senior but a staff level engineer. So going further, it does not give you automaticity. It gives you an eventual consistency and define the recover part. Okay, well, what is eventual consistency? As the name suggests, eventual consistency is, as the name suggests, your system is not yet consistent. It will be eventually consistent as you have more and more records. Imagine a kind of a voting algorithm. More votes over to the right or the actual candidate, then you have consistency. DynamoDB works in this way. I know this is all because of CAP theorems. CAP theorems, you might know, is consistency, availability and partition tolerance, and we can anyway take only 2 from these 3. That's the way even we chose for eventual consistency. Yeah, anyways, let's see. The trade-off is visibility and complexity. Sagas are harder to reason about than a single database transaction. Okay, well, let me give a guess because we are coming more at Saga. A saga, you see, a saga is a sequence of local transactions. I'm sidetracking to let you guys understand what saga is. If you're not aware, if you're aware, just skip the video. A saga is a sequence of local transactions, like across a multiple services. Each local transaction, like, does it work on commits to its own DB, or publishes an event or message to a trigger to a next step, and if any step fails within this, compensation transactions are executed to undo this prior steps. And yeah, this is where the saga pattern outshines. And if I can just take a classic example, like if an inventory fails after payment succeeds, compensating transaction refund the payment. You see, this is where the sweetness of this thing is. And there is no global rollback as such. You just explicitly undo this thing. So this is what a saga pattern is. Again, you can just click the video on here and you can get to know. But a single database transaction across 5 services is not an actual option at a scale because it requires two-phase commits. Exactly, because which is slow, fragile, and does not compose well under failures. See, slow is not a problem for now, but again, if you're strict with an SLAs that you have to deliver this amount of results, then slowness is a problem. Again, fragile, I can understand, fragile it is, and it does not compose well under failures. Again, if it is not implemented properly, this kind of pattern becomes a mess. A personal experience. So strong candidates reach idempotency keys and state machine. Exceptional candidates recognize that harder problem is coordinating states across service boundaries, and they can name at least one pattern that addresses it. And this is where you can grow as an engineer. As a software engineer, you just focuses on a feature, but as a senior engineer you focus on a service, and now as a staff engineer you just not focus on your one service but services across your organization. That how my service would be going to link with others. Again, the boundaries are blur. Maybe a staff engineer can go beyond this and understand that, hey, what are the business implication? Why am I spinning up this service? Can these two services be mingled to one another and just act as one? Because again, I'm spending another cost on infra and filling the pockets of Bezos. I don't want that. Cool. What Stripe actually cares about? Stripe's engineering culture. Well, engineering culture at Stripe, it's one of the good one I have heard, because good brains work over there. And I'm not sure whether it is true, holds true right now as well, but that's what my thinking was, and I just shared it. Based on its public writing and talks, is built around correctness, reliability, and the ability to reason correctly about failures. The system design question is a proxy for all three. What the interview is really measuring is not whether you know the word idempotency. Most engineers with a few years of distributed system experience do. And this is very common. They are measuring whether you think in terms of failure surface or not, and this is where the things outshine. As you grow, you don't look to give a solution. You look to give an optimal solution, and you look to give an optimal solution which would work within a failure conditions as well. You cannot rely on things, because people, it's all credibility. People would rely on you because you don't rely on something. This is the law, sadly. Again, let's not distract ourselves. Can you identify where your solution breaks? This is a critical part. I guess as a software engineer, this is a core skill you can have. Just don't fantasize on my solution is the best. Can you explain the trade-offs of your fix? Can you see one level deeper than your obvious answer? The reusable mental model is this. If your operation has no side effect, idempotency comes for free. If it has a side effects, you need idempotency key plus the state machine. If it has side effects and calls other services, you also need a distributed coordination strategy, whether that is a saga, outbox pattern, or the explicit compensating transaction. The sentence you can use in any system design is exactly once semantics in a distributed system require idempotency at an application layer, not the transport layer. And this is good. Stripe processes payment at a scale where a single missing guarantee, idempotency, turns a network blip into a customer support crisis. The system design question is not really about Stripe. It is about how clearly you can think under the conditions where nothing is guaranteed and everything has a cost. This is so awesome. I love this line. It's about how clearly you can think under the conditions where nothing is guaranteed to work. The same thing which I mentioned earlier, or I just gave a gist about, you cannot rely upon. That's how people would rely upon you. The next hard problem in this space is cross-service idempotency in the saga level. Okay, we are entering into the saga pattern more and more. You can stop it over here because again it dwells deep into the saga level. If you wanted to know more, again you can go ahead and check yourself on your own, search on. But again, if you wanted to stick, please. How do you make a compensation transaction themselves idempotent so that the recovery is safe to retry? That question deserves its own deep treatment. Yeah, it can go in a way that, hey, this question can have its own system design interview. It is that good question. And it is where the most interesting distributed system work is happening right now. If this topic interests you, it did interest me. The related piece of saga handled in distributed system, whether okay, cool. It is the ending notes, but yeah, man, I did like this kind of thing. I loved this thing. I loved this article. This is behind a paywall, so I would just mention the article over there. It's based on you. If you have the subscription, you can go ahead and read it, or else you can just rewatch the video. I'm not sure, but this is what it is. I would just wanted to share my thoughts. I got my eyes on this article, and this is fun. Keep learning. Thank you.